Have you ever wanted to just talk to a computer? Give it an instruction and have it do exactly what you want? Well, that's really all programming is. It's just learning a language to have a conversation. So today, we're going to learn the basics of one of the simplest, most powerful languages out there, Python. Let's get this first conversation started.
Okay, so imagine this. You sit down, you type 2 plus 3, and you hit enter, and instantly the computer replies with 5. Simple, right? But think about it for a second. It's kind of like magic, isn't it? You gave it an instruction in your language, and it just understood. It did a task for you.
But how? Seriously, how did it know what that little plus symbol means? How did it understand our human symbols and turn them into an actual action? That's the core question, the big mystery we're going to unravel in this explainer.
To really get how this works, we need to peek behind the curtain a little bit. We're about to meet the secret go-between, the translator that makes this entire conversation even possible.
So check this out. This slide shows the huge gap we're dealing with. On one side, you've got what we write, Python. It's designed to be clean and readable for us humans. But computers, they only speak one language, and it looks like that mess on the right, a long, long stream of ones and zeros. It's called machine code or binary. So, how do we bridge that divide?
Well, we use this little guy, an interpreter. The interpreter is basically the hero of our story. It's a special program, and its only job, its entire purpose in life, is to be a translator. It takes the Python code that you write and translates it, line by line, into the binary machine code the computer can actually understand and execute.
It's really just a simple three-step dance. 1, you write a command in Python. 2, the interpreter instantly translates it into machine language. And 3, boom, the computer executes that command. And this happens every single time you run code, all happening lightning fast in the background.
So, we know the computer only gets machine language. But what is that, really? What does it actually mean to think in ones and zeros?
At its core, it's actually incredibly simple. The computer's brain is basically made of billions and billions of tiny little switches. And each switch can either be on or off. We just represent on with a 1 and off with a 0. And that's it. That's a bit. And by combining billions of these simple on-off switches, the computer can represent literally everything. Numbers, letters, images, you name it.
Okay, enough theory. Let's get our hands dirty and learn our very first words in Python. And honestly, the easiest way to start is by turning our computer into a super-powered calculator.
Think of these symbols as your first little vocabulary list. In programming, we call them operators. Just like in math, plus is for adding, minus is for subtracting. For multiplication, we use the asterisk, that little star symbol, times. And for powers, like say 2 to the power of 3, we use a double asterisk, double asterisk. With just these 4 symbols, you can already tell the computer to do some serious number crunching for you.
And here's some really good news. You don't have to relearn all the rules of math. Python automatically knows the order of operations. Remember PEMDAS or BODMAS, depending on where you went to school? Yeah, it knows to do powers first, then multiplication, then addition. It's smart, and best of all, it's predictable.
Doing calculations is cool, yeah, but where things get really powerful is when we can make the computer remember stuff. So let's give our code a memory. Okay, this right here, this is probably the single most important idea to get right now. A variable is nothing more than a box. That's it. You just give the box a name, a label, and then you put something inside it. That something could be a number, it could be some text, maybe the result of a calculation. The computer then holds on to that box for you, ready for you to use whenever you want.
Now listen up, because this is a classic beginner trip-up. In programming, a single equal sign does not mean is equal to. It's an action word. It means assign, or put this value into the box. So when you see a equals 5, you should read it out loud as a takes the value of 5. Now, if you want to ask if a is equal to 5, that's when you use the double equal sign, double equals. That's the question.
So, okay, we can make the computer remember things. Big deal, right? Well, yeah, it's a huge deal because now we can start to make our code smart. We can make it reusable and flexible, and we can start to solve some really interesting problems. All right, let's look at a line of code that totally breaks the brain of every mathematician out there. X equals x plus 1. In algebra, this is an impossible statement. It makes no sense. 0 can't equal 1.
So what is going on here? How can this be one of the most common and useful lines of code ever written? Well, the secret is remembering what that single equal sign really means. It's not a question, it's a command.
Remember, The computer always evaluates the right side of the equal sign first. So here's what it does. Step 1. It looks inside the box called x. Let's say it finds the number 2 in there. Step 2. It adds 1 to that value, so it gets 3. And finally, step 3, it takes that new result, 3, and puts it back into the box x, replacing whatever was in there before.
This whole process has a name. It's called incrementing, and it is fundamental to programming. I mean, anytime you need to count something, like how many times a user clicks a button, or how many items are in a shopping cart, or how many levels you've beaten in a game, you are using this exact logic.
And this is where you see the real magic of variables in action. Look at the left side. We've hard-coded the numbers right into the formula. If the mass changes, you have to go hunting through your code to find and change that one number. But look at the right. We use variables. The formula resultat equals mas times g times hota is suddenly clear, it's readable, and if the mass or height changes, you only have to update it in one single place. Your code just became 1,000 times easier to understand and maintain.
So let's do a quick recap of our first conversation. Python is our human-friendly language. The interpreter is our awesome personal translator. We've got operators like plus and star to perform calculations. And most importantly, we have variables, which are like labeled boxes that give our code a memory.
And that's it. You now have the fundamental building blocks for communicating with a computer. You know how to tell it to calculate things, and you know how to tell it to remember things. That's the heart of it all. So the only real question left is, what will you tell it to do next? What are you gonna build?